Hey, so hello all. Thank you for having me here at RequireLex. My name is Pedro. I made a talk here, I think a couple months ago before summer. I don't know if some of you guys attended, about moving from MongoDB to Postgres. And this is basically 2.0, so our next step over. I'll give you my honest and humble opinion, so expect everything. So I work at BEN, which is Branded Entertainment Network. We basically work with movie industry, influencer industry. You've never heard about us, but you've seen movies where we put it product placement. Basically, I don't know, think any movie you thought of and any car that you see, any magazine, I don't know, everything, it's paid for, and we do that. Basically, I do mostly backend, some front end. I love JavaScript, and I organize Barcamp LX. I don't know if you guys know. It's also a meetup here in Lisbon. We'll have an event next month, 30th of November. So if you're curious, look us up. So I've been working on a single page application for almost 3 years now at BEN. We did a lot of things. So we had microservices. We moved to monolith because they weren't really microservices and they weren't helping a lot. We moved from Mongo to Postgres, and now we're migrating from REST to GraphQL. I'm here to tell you my humble opinion, and yeah, it will be very happy and not so happy sometimes. Just before we start, how many of you have worked with GraphQL before? Okay, not many. It will be an introductory talk, but yeah, some things a bit more advanced, but yeah, stop me if you don't follow something. So what is GraphQL? So QL stands for query language. So it's not a traditional programming language, right? It's not C or Java, much more like SQL. So it's a spec, right? It's a huge spec with tons of pages. But you can implement your own GraphQL like SQL. There's Postgres, there's Oracle, MySQL, SQL Server, whatever. And like in SQL, basically you just declare what you want, and then the database does the work for you and gets you all that data that you needed. It's the same thing for GraphQL, which is awesome, right? Because it's declarative and everything. You just type in the query and you get all. You don't have to worry about performance, bottlenecks. You're just consuming an API, except if you're doing it, because it's a pain in the ass. I don't know if you guys probably have experience with SQL, but sometimes you do a query and you're expecting to take like, I don't know, a couple milliseconds, and it takes like 20 seconds and you don't know why. And you cannot, you put indexes in it and it doesn't work. Yeah, because it's declarative, you have no real power on what's going on beneath. Then you have to pay for a really high-end DB admin to do the work for you. in GraphQL, it's mostly the same thing. So the main concepts is that there are queries, that's how you get data back, and there are mutations, that's how you change the data, how you create new entities, how you update them, and link them between. There's a schema, which is pretty nice. So basically you have to define all the types that can map to your database. There's even some cool libraries that if you have a SQL database, which has schema, right, inherently, looks up at your schema and basically gives you an ORM for fetching and getting the data. It basically creates all the types you need and maps all the data, which is pretty nice because everything is a graph. It's actually a tree, and you basically can switch around and play. And I don't know, it's ask for someone, and then his granddad, and then his granddad, and so on and so forth, without just declaring data, which is very nice. Except it isn't. So yeah, when you're reading stuff, it's a graph. It works magically. You define the types, and basically you define the relations. You see that a parent has a child, and you're fetching the parent, you get a child. It's awesome. If you're doing an update, no, it doesn't do anything for you. You have to do it all over again, as you had with REST. If you're, it's It's not the brightest thing in the world, because since you already have to create a schema, yeah, why not figure out how to make the proper updates? This was one of the first things that really bothered me with GraphQL. Was while I was thinking on it, okay, it would be nice to send a graph of all the data you want, right? I don't know, you're in the UI playing or some service, you change, I don't know, the parent, the child, the grand, you change a lot of stuff, the relation between them, and then you just, boom, push a graph, and then it automatically updates. Doesn't do that. It's a pity. But yeah, so a schema. So you have to define types, and you have to define input types, which is also dumb. Basically, you define all the relations, right? This is very similar to what you would have to do in an ORM logic when you're defining all the relationships between your entities. This is how GraphQL will understand that a person has a parent and has pets. Pets is an array, so you can have multiple pets. You have some native types like integer, string, floats, and that's it. You basically don't have a lot of things. You have to do most of the stuff by yourself, even dates. So yeah. Then you can have queries and mutations. Queries, as I mentioned, how you get data. Mutations, how you update the data. Basically, on the query here in the person is basically the filter. You can pass whatever params you want. I don't know if you want to search by name, search by ID, search by, I don't know, give me the top 10, something like that. And this will output you a person that basically it's like copying this bit into here, and you can then play around, and you can even do recursive stuff, which might kill the API, which is not nice. Yes, updating, you need to define what you want to receive on an update, not a graph. You can try to, I don't know, do yourself that logic and receive a graph and try to do it. We kind of try that because we are using SQL and we have all these definitions here also on the ORM logic. And the ORM knows how to update stuff, which is awesome. So you can pass a graph to an ORM and it will update all the relations because you say that this is a many-to-many, this is the one-to-many, this is whatever, and you will know. These won't know. Yeah, so this is an example, as I was telling you about. So a person, you get the name, the age, you get the parent, you get the pets. The pets is an array. So yeah, you can query a lot of data. You query only the data that you need, which is awesome. It's how the UI guys want to sell this, right? But for the API folks, this is also very good because imagine a SQL database, you know what to get. So if you're fetching for a person, you don't need to fetch all the 40 columns that you have on the database. You only pick the 2 that you need, and that speeds up things a lot, especially if the payloads start to be really big. The bottleneck starts to be the traffic, right? Over the internet, right? So it starts to slow down because it's so big to load the things. And a mutation, an example. Basically, we are saying that yeah, this could have an ID, of course, but this is just a simple example. We're saying okay, pick person with name Mary and set its age to 30, and then return yeah, whatever, the same thing. You see here that it starts to be nested, so you could have parent, and then 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 parent, and parent, and parent, and if you had a child, you can go the way over. There is a default limit, I think it's 5 or 6 nested things, but yeah, you guys need to be careful with that, because even 6 layers might be too much. These names are completely random. You have to choose what you want. For us, it made sense to call one thing payload and just receive all the stuff there, but we could have like just name and age directly here, right? And maybe leave other crap. I don't know. When we do this, like the first element is the filter, right? Which person you want to change, or if you want to change multiple ones, and the second one is what you want it to change. Okay, so resolver. What is a resolver? Let me scroll up just so you guys know. Every time you call a name, an age, parent, name, this is a resolver. And basically, if you don't set anything, any code on it, it will default to, when you fetch Mary, right? It will default to Mary.name, default to Mary.age, Mary.parent. If you don't have Mary.parent set, it won't return you anything, right? But basically the default is whatever you received from the database. Usually, you can also have an API as a database. But then you would need to do more advanced stuff. For example, for the parent, right? Because you don't have the parent when you do a lookup on the database. So at that point, you could do get me, based on the entity I had before, get me my parent or my grandparent or whatever. A resolver always has 4 arguments. First is a root, which is whatever it was there before, right? So if you're talking about the pets resolver, right? At the root, you will have the person, right? The person who owns the pet will be there. The arguments is whatever you passed in the initial flow. The context, it can be, for example, for us, it has stuff like the request, the original request, HTTP request, where you can have the request ID, so you can log stuff properly and not. They have things like data sources, which is basically how they think you should fetch data. They should always use a data source. So context.dataSource can have whatever information you hold, which is very, very nice when you're playing with multiple APIs and multiple databases, because it's like you're accessing data and that's always the API. You have to look like context.datasources.fetch person via Google API. It doesn't matter. You can do whatever, which is pretty nice. And then the info is where all the magic lives. So because you see these trees, this basically gets computed, right? And this gets into the info. There is no docs for it, but what we did is play with it, see what it has, and that's how you can know that, for example, you asked for only the person name and age, so you don't need to fetch all the other stuff. So basically what we do is we grab the info, we parse it, and we grab whichever fields we want to select and only pull those from the database. But it has a lot of stuff because you can do, it's a bit of a mess, and traversing it, it's very strict. It's the pattern is very well written, but it's not easy to go around, and especially because there's no documentation, it might break in future, but we'll see. So the GraphQL will know what to call, so the resolvers, what to call based on the schema, which really help you if you have very nested data. When you're dealing with the pets, you only need to know what's the parent, so what was the person that owns the pets, and for this context, for this small task, what do you need to do? You don't need to worry about if it's 3 layers down, or I don't know, if it original came from the request came from, I don't know, proxy, the user that made it. You don't care. It's very, and this is one of the really good things. It's very confined into the thing you're trying to resolve at the moment. You don't have to worry about dependencies at this point, except for really edge cases, but it's really nice. For mutations, it doesn't help you. Nothing. It doesn't help you. It's basically you have to redo everything as you had in REST, which is a good thing, at least for us, because it's very hard to change legacy code. But since you're already redoing it, okay, let's start from the beginning at what would you do. And like Luis showed before, it's very hard to change it. And if you can do it step by step, mutation by mutation, it will hopefully reach a good state. So it's not an ORM, which is very painful. I think it could be, I don't know. It would be really interesting if you could just send the graph and the UI and it will magically update everything that you wanted. It would be awesome because we are doing that, but we have to define it ourselves in the ORM logic. I don't know if you guys are familiar. We're working ORM, but when you define those relations, it then knows how to update stuff. So what you can do batches, so you can in the same request do multiple operations, which is awesome. But then it's very bad because it doesn't support transactions, and if you get an error, for example, in the second one, in the second request, in the second operation, there was an error. The next one should continue. Should it stop? You decide. Implementing yourself. Yeah. So it's not fun. It's good, but it's like halfway. The Schema Explorer is very, very, very nice. So you can basically, it's natively when you install, for example, stuff like Apollo. And if you like that example of having a SQL database, basically you can browse your entire database, know everything about the schema if you're on the client side. So because sometimes the documentation is not good, sometimes there is no contact with the developers, and it's awesome to be able to look what are the types, what these links to, what can I send in this thing, and the doc's really, really, really good, which is awesome. Then there's a subscription for you to learn about when stuff changes, and then there's middlewares, which I don't know if you guys like it. It's not great because yeah, you never know when things are going to run, but it supports it, which is nice, but it's nothing new, right? Every framework supports this kind of stuff, except maybe the Schema Explorer, which is very, really nice. So it's just old concepts, but built into a new language. So comparing it to REST, and these things, like the first time I looked into this, was like, oh, come on, how can this work? You just have one endpoint in your API. It's like, wait, what? How do you do performance? How do you do stuff? No, you just have one endpoint. It's like / you can name it, of course, anything you want, but it's /GraphQL, and it says it's a post, and it always returns 200, except if you do stupid things. Of course, you don't say in the invalid JSON or stuff like that. So yeah, at the beginning it's like, oh, come on, how does this work? How can I know what's happening in the server? I'll show you, but yeah. Queries are similar to GET requests, and mutations are all the other post, put, patches, kind of. Basically, you state what you want to change, but yeah, you have to implement it just like REST. The payload. So when you're sending, and this is the thing, the payloads will be massive, because the payload holds all the things you want back that you are sending, and any variables you want to, right? So that mutation I was just showing you basically gets mapped into this, which yeah, initially is not great, then is awesome. Also, when you start and you want to debug these and look like into the network tab, it's a pain in the ass, but there are a bunch of extensions that you can use. It will parse you this very nicely. Yeah, if you want to make requests, there is Postman. Postman is not great for using as an HTTP client for this, but Insomnia, I don't know if you guys know, you can basically just copy the full thing, select the payload, the request, paste it there, select GraphQL, and it will be magically pretty again. The response, yeah, always 200, right? So there is an errors. Fortunately, an errors array, it can be null, and there's the data. Because we only had one operation, the data is just this. If we had batching operation, the data will be nested inside each of the names of the operations, and yeah, and this will grow a lot. You see that the payloads and the responses start to be really, really big, but it's a trade-off because your API is much less chatty. You do one request to the server and you get everything you need to load the page, for example, or most of the stuff, of course. But you receive much more data, which is you don't receive that much because you only get the things you want, but you get all the things you want. So yeah. So what's good, and there are a lot of things that are great in GraphQL, especially if you're on the front end side, because you only have to consume the API, you don't have to implement it. You just have to declare what you want, and if you asked for too much stuff and it's taking 20 seconds to load, I don't care. I just ask for it. You fixed. You're the backend guy. Yeah, I passed the last 2 days working on performance. Yeah, but it's nice. There's some great tools to have it, which is very, very, very nice. This performance tracing thing, it's pretty awesome. So let me scroll up a bit just to show you. In here, if it's enabled by default. You just pass a flag saying you want tracing back, and it'll create you here a new thing that will tell you for every resolver that ran. So for the the person, for the pets, for the parent, parent, and or all the chain, it will tell you how long it took. So if you're looking for a performance bottleneck, it's really easy to see what might be wrong. Documentation, again, it's really nice, the documentation. Having multiple data sources. In our case, the most we use is basically Elasticsearch or Postgres as two different data sources, but you can have a full API behind a data source, which is very nice because it's very easy to hide all the logic and make it very inside silos and containers that just talk to each other, and you don't have to intertingle with them, and it's very nice. And also caching, it's enabled by default, and it's a flag, and caching works. The bad is that caching is hard, and it doesn't work like that. So yeah, this bothered me a lot, because a lot of people think of caching. Yeah, let's do cache. Let's implement it. And Apollo is like on the docs. If you read the docs, like pushing you, and even GraphQL data loader, everything is pushing you to implement cache. But it won't work in some cases. And when it doesn't work, it's a real issue. It's not. It depends on your application, of course. But when cache is playing bad, it plays really bad. So it's one thing to be very careful when implementing, especially in our case. If you're playing with REST and GraphQL, and REST as a cache, and GraphQL will have another cache, and you do updates to the same entity via two different endpoints. How do you work out the rules? Yeah, best not play with it until you're very incredibly sure that you really want to make cache. So generalizing cache, yeah, I think first you need to look at the data, see if you need to, and then do it. Schema validation is very painful. We work with Happy.js. It's a Node.js framework on the backend, and don't know if you guys know Joy. Probably it's the most used validation for schemas on JavaScript, and it's very powerful. You can define crazy things, like if you're sending name then age must be between, crazy stuff. With GraphQL, you have 5 types or 6, and you have to define yourself the JSON thing, you have to define yourself the date time, you have to define everything, which, yeah, it's not ideal. Even if you have the definition behind, your definition behind, right, you still need to have some kind of schema there, which is not great. API versioning. Yeah, so if you just have one endpoint, how do you version stuff, right? You can do it yourself. Basically, you have to do it yourself because it doesn't tell you how. It just has one hint. If you're on the documentation, you put a tag saying @deprecated, it will be marked as deprecated in the endpoint. And if you try to fetch that property, it will tell you that it's deprecated. But that's it. So, and everyone that has an API that can be called an API should be thinking about versioning, right? So they don't tell you how to do it. Basically, you have to figure it out by yourself. So I don't know, maybe passing a param on every query, on every mutation. But yeah, it's not properly thought through. Handling custom errors, also a thing. Yeah, it's not easy. It's like it's moving very fast, but there's some stuff like you have to do kind of hacks and extend methods where you could just pass a config. It's still not. It's very powerful. It's very good, but when you're trying to deal with all your edge cases, expect a lot of work. Expect a lot of work to make it work with everything. Yeah, and now the ugly stuff. Middlewares, it's a mess. I don't know if how is your experience working with middlewares, but for me it's not great. You never know what is running when, where, and ordering stuff. It's not great. And the only way for you to change the request, or I don't know, to for example apply permissions on a request, say that this user cannot request for that thing, is through middlewares. So it's yeah, and especially working with Happy.js, which has a very nice request lifecycle. the middleware seems a step back. Another thing, there's no inheritance in schema. I don't know, they didn't thought about this. Is basically, I don't know, if you have, in our case, we have films, right? You have films, everybody knows what films, but films are different types, right? And if you want to have, I don't know, action movies have some property that's different from comedy, you basically have to define both of them with all the things that common in, and copy, paste, and copy, paste, and copy, paste. It's done. Also one thing, if you're, in our case, a person and the person input type, right? They are the same. Basically, you can ask for a person and you can change the same things you can ask for, which it's pretty normal. You have to define two types. And while if you're copying two types, there are some libraries that allow you to do this inheritance piece, but they will do it by yourself, the copy pasting. If between a type and an input type, you cannot copy things, which, it's also, I don't know. Probably these will change. This has to change in the future. Schema permissions, if you guys have an API, some external users cannot access the same thing as an admin, as an internal, as someone else. So how do you deal with not showing the salary if you're, I don't know, if you're like talking about an HR application, not showing the salary for people that are not logged in? The schema is global for everyone. It's not obvious how you can do it. You can. Initially, we tried to play around with the info object, and it was a mess because, this was very odd. The info basically tells you the structure of the T and all the schemas, and we would say, okay, the request is coming in. We'll say, okay, the user is external, so we delete it from the schema, this field, and you wouldn't have access to it. The next time another user tried to use the thing, this was the object that's supposedly created during the request, right? An admin would come in, it would disappear from the schema, the thing. That's not great. Last thing is parent-child relation. Don't know if you guys heard of this N+1 problem. Basically, you can nest stuff a lot. And if you can imagine that you get one function call for this, one function call for this, one function call for this, and so on and so forth, it starts to grow a lot. So at the first time you fetch one entity, and then for every child you fetch its child, and then for every child of the child you fetch its child. It grows a lot, and by default there's nothing you can do. So, but you can be smart. So if you're looking at the database, this is a solvable. It's obvious, right? You just join tables by key and you fetch whatever you want, and this is blazing fast. This is as fast as you can imagine on any proper database. But in GraphQL, the default approach is basically, you have to run through the array and loop and do finds and finds and finds and finds. Of course, there are solutions to this. There's a model everyone uses, which is called data loader. They basically try to solve this, and it uses caching and batching, and you have to build your own crazy logic. So basically, you have, this is the last bit, and let me try to, because I've dealt with this problem for the last 2 days, and it's a mess. But it works. So imagine that when you want to load a person, you pass the ID of the person. You just ask, I want this person. And then on the next resolver, I want this person's, because you know always the ID from the parent and so on. You just call them. And what about, you don't make the request yet, right? You wait at the next event loop. When it stops, the event loop, you basically go, okay, what all the queries that was called, let's look at them, and now let's run them through, right? Which seems nice, but basically you have to parse all the filters that you got. I don't know, query 1, search for user 1, then 2, then 3, then 4, then 5, and then 10, and then you get an array with all the filters that were used. Now I want to get these people. You have to parse it all over to make it readable for your, so you can make it a SQL query, for example. So you can do a where in or whatever, left join with tables. So yeah. Okay, thanks a lot, guys. Yeah.